Hello everyone, myself Juli Yadav. I am assistant professor in Ajay Kumar Garg Engineering College, Ghaziabad. So today's topic of presentation is unification. Before proceeding towards the unification, firstly I want to make you know about why I'm talking about this topic unification. Basically, it is a feature in Prolog programming. What does this Prolog programming is? Prolog programming is stemmed from programming in logics that is used for doing the programming. Means a Prolog programming is basically a method, or it is a way of programming to make the system or to make the devices, artificial devices, intelligent as the humans can. Then how we can make those devices intelligent? If we are applying the logic, then only we can make the artificial object intelligent as the humans are. So we need to apply a logic in the artificial object. So that logic can only be possible in applying to the artificial object by using of the Prolog programming. That is a programming in logic. Basically, a Prolog is a declarative language, which means that the program consists of data based on the fact and rules. In Prolog programming means the logic that we are applying, that is based on these statements, declarative statements that uses generally the facts and the rules. Means what is the fact and what is the relationship between those objects that we are using to define the fact. So to obtain a solution, the user may ask a question. In Prolog programming, generally what we do, the user asks a question. Means the logic has been applied in such a way that we are applying the we are trying to introduce the logic in terms of questionary forms. Means you or we are asking some questions and the output comes in the form of yes or no. That is the logic, right? In Prolog programming, logic generally expresses the relation that is known or that is called by the facts and the rules. Core heart of Prolog lies at the logic being applied. How we are applying that logic in the or how we are applying that logic to make the artificial object as an intelligent like the human. So for this, we need to do some sort of computations that are running on different relations. So Prolog has many applications. Like Prolog is basically used for specifying a particular language. We can also plan a robot, how we can make a robot intelligent. We can also use the Prolog programming in natural language processing. We can also use Prolog programming in machine learning. We can also use Prolog programming for solving different problems that are related to our day-to-day life. We can also use Prolog in solving those problems, or we can write the logic for solving those problems. Prolog programming is also used in expert system, or it can also be used in automated reasoning. So the basic syntax for Prolog programming is generating some facts, and we constitute the knowledge base according to those facts. So generally the logic is in the form of the format is in the form of like the relation, and then the entities. There can be many number of entities. So by using commas, we can separate those entities. If we are applying the logic, or we are trying to write the program in a Prolog language. So here relation and entities. For example, if we take Ram and Shyam. Ram and Shyam are brothers. Then in prologue programming, how we can write this fact that Ram and Shyam are brothers? So in prologue programming, we can write it as, first we have to write the relation, because the syntax tells what is the relation and the entities. So the relation between Ram and Shyam is brother and Ram, comma, Shyam. So in these ways we can write the facts and we can apply the rules that are related to those facts and what is the relation between those facts. So there are n number of features that are present in the prologue programming. Few of the features are like unification, resolution, backtracking, recursion, and many more. So today I'm talking about unification. What does this unification is? So before proceeding towards the unification, I want to make you know what does this word unification means. As the word itself says, unify means something, two different things, we are making them identical. So what is unification? Unification is basically a process of making two different logical atomic sentences identical by finding a substitution. Basically, we applying a substitution technique. What we have to do in substitution? Suppose we want to find the value of x and the value of x is related to y. So how we can do the substitution? First we have to either calculate the value of y or either calculate the value of x. Then we can replace those values in this expression, right? So this is how a substitution basically works. So unification depends on the substitution process. Means there are two different things. Suppose if x is equals to y plus 2 and another one is x is equals to y plus 3, then these two expressions are completely different. Then by applying unification, if we are applying the unification process, then we have to make these two expressions identical. Identical in the sense, either make the first sentence as the second expression or make the second expression same as the first expression. So this is what the unification is. So here is a term as two different logical atomic sentences, expressions. What does this means? Logical atomic expressions means the totally different sentences or the expression. Like here, we can take an example like Raju and Mahesh, or Rani and Mahesh are friends. One sentence is this, another sentence is Ram and Shyam are brother. So these two individually, if we are seeing them, then this sentence, Ram and Shyam are brother and Rani and Mahesh are friends, they both are identical different. There is no similarity in both the sentences. So we can call them as logical atomic expression. Atomic expression here I am using because they are means there is no use of any connectors. Connectors like conjunction, disjunction, negotiation, implication. If there is no use of those connectors, then those sentences are known as the atomic expression. Means atomic means there is no use of any connector for joining two sentences. These two sentences are individual. So it takes two literals as input and make them identical using a substitution. Somewhere here we are taking some sort of values and we are substituting those values and then we can make them as similar. Means two different expressions can be made similar by applying the unification process. So here we have taken two values or the two symbols like psi1 and psi2. Here psi1 and psi2 represent the sentences, atomic sentences. Like for example, we can take, if this one represent Ram and Sham are brothers, we can call it as psi1. And here is Rani and Mahesh are friend, then this sentence or this expression we considered it as a psi2. So we have to make them we have to unify these two sentences. These two, psi1 and psi2, both the sentences are different, and we have to make them identical. So atomic sentence, and this be a unifier such that psi1 sigma is equals to psi2 sigma. Then it can be expressed as unifier psi1 comma psi2. Means this sigma is some value that we are placing either in the first expression or in the second expression to make them identical. So in some cases we can replace the value in the first, we can substitute the value in first expression. In some cases we can write the value, the substituted value, in the second expression. So that's why here sigma is used. So here is an example. Find the MGU. Here MGU is most general unifier. Means it is the term that we need to find. Means the values that we are substituting either in the first expression or in the second expression, that comes under the MGU, most general unifier. So here is an example. We have to unify, there are two atomic expressions that are not identical, means they both are different. First expression is X is a king, means some X is there which is a king, and another one is John. The X is replaced by some other word, that is the John, means John is a king. So these two sentences are atomically different. So how we can make them identical? So here let us assume psi1 is king of X and psi2 is king of John. So let us say there are two different expressions, P of X comma Y and P of A of X, F of Z. So this is another example. So the most general unifier for this example, how we can find is which term we need to replace in, either we want to replace in this or we want to replace in this. So this can only be done or can be replaced if we are following some of the facts that need to be followed while we are applying a unification. So before I'm explaining this example in detail, I want to make you know what are the facts that need to be followed to make the two different terms as identical. So here is another example also. Here this one is an expression, this one is an expression, this one is considered as psi1, this one is considered as psi2. Here this is the substitution term, means X is replaced by A and Y is replaced by F of Z. If X is replaced by A, then it becomes A, and Y is replaced by F of Z, then the first expression will become like as it is, which is similar to the second expression, that is psi2. So in this way, here is the that is substitute X with A and Y with F of Z in the first expression, and it will represent as A. How we have to represent it? We have to represent it as A slash X. In this way we have to represent it. Means the value that is represented or that is replaced, that has to be right in place of this value. This one is the value that has to be replaced, and this one is the value that has to be right after replacing that value. with both the substitution, the first expression will be identical to the second expression. So here are the conditions for unification. So the first condition is predicate symbol must be the same. Atoms or expression with different predicate symbol can never be unified. Here we are talking about the predicate symbol. You might have heard that there are two predicate symbols, that is the universal, that is represented by for all. We call it as universal quantifier. Universal quantifier, and there is another symbol, extension quantifier. These two quantifiers, if they are present in any of the expression, then if both the expression contain the same quantifier or same predicate symbol, for example, if there is an expression for all x, and if this is expression 1 and if this is expression 2, then these two expressions cannot be unified. Why? Because they have different predicate symbol, or we can say they have different quantifiers. If their quantifiers are same, in place of extension quantifier, if there is universal quantifier, then we can unify these two expressions. The first condition is that. The second condition is number of arguments in both the expressions must be identical. Second condition is, if there are, suppose here I am taking v of x which contains p of x comma y. If this is the first expression and v of x p of a comma g, if this is the second expression, then what the second condition says? The second condition says, if the number of arguments in both the expressions must be identical. Here, how many arguments are there? In first expression, there are argument 1, argument 2, means 2 arguments are there. Now we have to check whether the same arguments are present in the second expression. Here we can see the second expression also has the 2 arguments. So these 2 expressions can be unified, right? If there is another argument present, suppose here is x, then these 2 expressions cannot be unified. Why? Due to its second condition, that is number of arguments in both the expressions should be same. If there are 2 arguments in the first one expression, then there should be exactly 2 arguments in the second expressions, and so on. If there are 5 arguments in the first expression, then the second expression should also have the 5 arguments. Then only they can be unified. Now the third condition is, unification will fail if there are 2 similar variables present in the same expression. For example, what does it say? If this is an example, if p of x comma x, another example is v of x p of a comma y. If these two expressions, first condition is, let me tell you how we can check or verify whether the following conditions are satisfied or not. First condition is, first condition says that the predicate symbol should be same. So on the basis of that, we can unify these 2 sentences. Now the second condition is, number of arguments should be same in both the expressions, and the number of arguments are same as well. But the third condition says unification will fail if there are 2 similar variables present in the same expression. Means, for example, here p x comma x, if this type of condition is present in any of the expressions, then they cannot be unified. Why it cannot be unified? Because if we are replacing a in place of x, then we have to put x here also and here also. The expression will become p of a comma a and here the expression will be P of A comma Y, which cannot be equal or identical ever. So in these ways, these are the conditions which we need to follow while we are unifying any of the two expressions. So here is an algorithm. So let me give you a thorough review of this algorithm. The first one is we have to initialize the substitution set to be empty. Means if we have given an expression, then the initial, that we are finding MGU, that is the substitution term, that should be empty initially. Initially, we represent it as empty. Means initially it is empty as it does not contain any of the substitution term. So, recursively unify atomic sentence. If here is the expression P of X comma Y and P of A comma B, right? We have to recursively unify atomic sentence. First, we have to unify these two terms. Then we have to unify these terms. This is why here the recursive term is used. If there are 5 variables, Z, U, V, then we have to unify each parameter or each term one by one. We cannot unify all the expression, the complete expression at a single run. So, recursively unify, how we can unify those atomic sentences? So, first check for identical expression match. Then we have to check what is the expression that makes them identical, what we can replace, what we can substitute so that both the expressions will become identical. So, if one expression is a variable, if there is any variable present in any of the expression, then we have to choose that. And the other is a term. Means if one is variable, then other expression should contain some term which does not contain a variable. Means the expression that has the variable, that has to be replaced with that term. So how we can apply the substitution? Then we have firstly we have to check that which expressions have the variable. Then if we find the variable, then we have to apply this substitution. How we can substitute? Then we have to substitute Ti. Ti is the term that is present in that expression and Vi is the variable that need to be replaced with that term in the existing substitution. So then we can add this Ti slash Vi to this substitution that was empty earlier. So this will contain all these sets that can be made during this unification process. So if both the expressions are function, there can be the possibility that both the expressions have the function, then the function name must be similar. What does it mean? Suppose if there is a function P of X comma F of A, if this is a function and this is expression 1 and another expression is A comma F of G, then firstly we have to check the condition. The condition are like if there is any quantifier, then the quantifier should be same, but there is no quantifier, so there is no need to check the first condition. Second is number of parameters. Number of parameters are same in both the expressions. Third condition is what? There should be different parameters or the different value. They should be not the same value present in the same expression. That condition is also satisfied. Now another condition is there, that is we can unify this without considering any condition why we are unifying these. But when we switch to the next parameter for unification, here is a function. So the function can only be unified if they have the same name. The function name must be similar. If suppose here is in place of f, if there is another function v, then these two functions cannot be unified. So make sure we have to check that the function name should be same. Then only we can do the unification. Plus one more thing also there. After matching that the function name should be same, then the number of arguments present in the function be the same in both the expressions. Suppose if here is f of a, comma, g, then in the second expression also there should be two parameters for that expression, else that will not be unified. So I hope you will get a clue of how this algorithm works. So here are some of the examples then we need to solve. So let's start with the first example, that is MGU of f, p of f of a, g of y, p of x comma x. So if this is the case, let us consider it as psi1, let us consider it as psi2. So the psi1 has how many parameters? 1 and 2. There are two parameters and there is no quantifier present in the expression. So no need to check the first condition. Second condition is number of parameters should be same. So here the number of parameters should be same. Then we have to go for the next condition. That condition is what? The expression should not contain the identical parameter, the third condition. Here you can see that x, they both are identical, right? So how we can unify them? This fails the condition, so we cannot unify them. If we are not, suppose we are not checking the condition, then how we can unify them? How we can find the MGU for this particular example? This one is our psi1. Let us suppose we are replacing f of, suppose it is the first iteration. In the first iteration, what we did, we find f of a should replace x, right? Then what we have to do? We have to replace all the x present in any of the expression. So the expression become, what an expression become? Expression become the first expression that remains the same, and the second expression, this one, this will become p of f of a comma f of a. So here you can see that these two sentences can never be identical. So instead of wasting your time, you can check the condition here. If the condition is not fulfilled, then it cannot be unified. So here the unification is failed. We cannot unify. Right? Now the second condition or the second example. So this one is the second example. So let us take the second example. What does the second example says? So the second example says, this one is the expression and this one is the expression. So first we have to check, is there any quantifier or is there any predicate present in this expression. There is no predicate, so no need to check for the predication condition. Next is we have to check the number of parameters. So let us see. 1 parameter 1, parameter 2, parameter 3. So in the first expression there are 3 parameters. Parameter 1, 2, 3. In the second expression also there are 3 parameters. Right? Then how we can substitute? So let us suppose psi1 is P of B, comma X, comma F of G of Z. This is the first expression, and the second expression is P of Z, comma F of Y, comma F of Y. So this one is the second expression. Now how we can unify them? So we have to unify them. We have to check which expression should contain the variable. Now here we can see this one is the variable because we have to represent the variables using the small letters. So this one is the variable. Then we have to replace this B. So replace this B with Z. What does it mean? Wherever there is B, we have to replace that B with the Z. So this was the first iteration. The output would be the expression 1 will become, or we can, this is the substitution term that we need to substitute. So the expression will become P of Z, comma X, comma F of G of Z. And the second expression is P of Z, comma F of Y, comma F of Y. Right? This I have done for the first expression. You can done for the rest of the expression. In the second expression, this one is the variable. So this variable can be replaced with this, and the expression will become P of Z, comma F of Y, comma F of G of Z, and P of Z, comma F of Y, comma F of G of Z. Right? Now the third expression. Here these two are same, these two are same, and this is already being the same. So there is no, here is F of Y. Sorry, here it is F of Y. So this can be replaced with F of G of X because here is only the function. So instead of G of Z, we can replace Y. Y can be replaced by using G of Z. So in this way, you can solve the rest of the examples. Thank you. And one more thing I want to make you clear. You have to represent the substitution terms, like B is replaced with Z, and in the second expression X is replaced with F of Y. So you have to mention, and the third one is F G of Z replace Y. So in this way you can write the substitution term, or you can call it as MGU. Thank you.